Welcome to our class on consumer behavior. This unit basically looks at the behavior of individuals, the capacity of consumers, and the impact of alternative incentives on their decisions. We are going to look at consumer behavior about how consumers decide on a basket of goods and services they consume. We're also going to look at consumer behavior in terms of decision-making and utility. Now that the economy has reached where it is now with your limited resources, fuel prices have gone up, transportation costs have gone up, electricity has gone up. How do you maximize satisfaction at the same time living within your means? So basically, this concept in economics is more practical, and I want to break down the theories in their own context. So we're going to look at these in terms of two key approaches, is what we call the cardinal utility theory and the ordinal utility theory. Utility, by definition, basically looks at satisfaction. How are we able to optimize or maximize consumption with the limited resources that we have? So when you're dealing with ordinal theory, basically, this is simply a theory of satisfaction that assumes that the price that one pays should be equal to the satisfaction that are we together so far? So we're trying to look at these theories and how they apply. So there's a theory, which is the ordinal utility theory, which is on the assumption that whatever you pay must be equivalent to the satisfaction you get. For instance, what you pay for tuition, either to me, to the school, should be equivalent with the benefit of the consumption you're having. So it's called the cardinal utility theory. So it assumes that the total utility derived from the units of one product or service that you consumed should sum up with the incremental satisfaction. So when you add them up together, they should be equivalent to the total utility. Then we also have another theory, which is called the ordinal theory. The ordinal theory cannot be measured. It is a theory we're going to use, which is based on what we call indifference curves. And difference curves are curves that have properties that we're going to discuss. They join points that offer the same satisfaction. They show or illustrate lines or curves that are downsloping that show a particular level of satisfaction. So indifference curves look something like this. So from what you can see is indifference curve 1, indifference curve 2, indifference curve 3. Now, who can give me any properties of indifference curves? Have you ever heard of this term, indifference curves? So from what you're able to see, these are graphical representations that we use to illustrate consumer preferences. So number one, they are convex. By convex, we mean they give the origin the back. So they're convex. That is the first property. The second property is that they are downsloping. So like I said, convex means what? They look like this. They are giving the origin the back. So it means that as you move along from the left to the right, consumers are willing to give up fewer units of one good to get more of the other. So this convexity looks like a trade-off. So if you're going from unit 3 to unit 2 of Y, maybe be gaining from unit 4 to unit 7 of X. So this is where the convexity comes in. Then they are downward sloping, meaning that the consumer will get more as you get more of one good, you reduce on the other. It's the same concept, but they're down sloping. They have a negative relationship because of the swap. As you increase in one year, it's reducing in the other. They are non-intersecting, meaning they don't crisscross. You cannot have a situation like this where you have one indifference curve and the other indifference curve meeting at a certain point. So these indifference curves do not intersect. So if they did, it would mean that a consumer would, at the point, endure satisfaction, and also at another point here, which obliterates the whole key theory of indifference curves. So this does not exist. Then also the higher utility means indifference curve 3 is higher than indifference curve 2, which is higher than indifference curve 1. So as you go up, you have more satisfaction. Are we together? The other properties are diminishing rate of substitution. So marginal rate of substitution, MRS, means as you move from the left to the right, you're willing to give up resources for the other. So these are properties that we needed to understand of indifference curves. So you could have two commodities, oranges and bananas, which could be illustrated on the indifference curve, A, B, C, D. So the law of marginal substitution simply tells that if you're going to move from point A to point B, from 18 units of bananas to 15 units of bananas, you need to gain this 1.5 to 0.5, 1 extra unit of oranges. So this is what we call a trade-off, opportunity cost. So this is how the indifference curves look like. And we've talked about the properties to say they are convex. The indifference curve has a negative slope. The indifference curve doesn't touch the axis, so it's infinite. It doesn't touch the axis. You also need to understand that indifference curves are, they don't crisscross. Indifference curve along the function of the curve is constant, meaning the marginal rate of substitution changes from one point to the other. So now I want to bring in the concept of the budget line. So in the area we live in, we're always looking at the economy and the cost of living, the budget line. So when we're looking at indifference curve, the budget line, at this point here, this is what we call constrained optimization. Constrained optimization. We want to see how we can maximize satisfaction at the same time. Any questions so far? So this is the budget line. So budget line simply gives us our amounts of good X and good Y that we can consume within the resources that we have. So it's given by income, which is denoted by I, then price of good X and price of good Y. Okay. So I stands for the what? Income. PX stands for what? Price of good X. PY stands for the price of good Y. So the budget line price of good X, PY, price of good Y. The income can also be noted by the letters Y or the letters M. So before I talk about constraint optimization, I want you to learn how to illustrate a budget line. So suppose that your income was maybe 100 kwacha. The price of good X was maybe 5 kwacha. And the price of good Y was 10 kwacha. How do we write the budget line? Income is equal to price of good X plus price of good Y. So this would be 100 is equal to 5X plus 10Y. So this is our budget line. So how do we plot? You get the intercepts. The number that is before the X is a 5. So 5 into 100, you get 20. The number that is before the Y is 10. 10 into 100 is 10. So if you're going to sketch this budget line, Y and X, you cut the X at 10 and the Y at 20. So you join these two lines here. So this is our income equation. So 100 is equal to 5X plus 10Y. So let's try. Suppose your income is 80 kwacha. Price of good X is 10 kwacha. Price of good Y is 4 kwacha. Who wants to help us with the budget line? How do we come up with the budget line? Yes, it's a period. Give me the budget line. Give me the equation of the budget line. Income is equal to price of good X times X plus price of good Y times Y. So here we have 80 is equal to 10X plus 4Y. This is our budget line. So how are we going to sketch this budget line? We calculate the intercepts. So the intercepts on the X, 10 into 8 is 80 is 8. 4 into 80 is 20. So if we're going to draw this budget line, on the Y, it will cut at 20. On the X, it will cut where? At 8. So this is our budget line, which is given by 80 is equal to 10X plus 4Y. Are we together so far? So we need to also understand that the budget has what we call shifts and tilts. So if you increase your income or you double it, you expand your equation outward to the right. When you shrink your income, it will move to the left. So this is a normal arrangement when we're dealing with our budget line, the income. So for instance, if you had an income of 100 is equal to what? 5X plus 10Y. So how do we sketch this? We divide our 5 into 100. What do we get? 20. 10 into 100, what do we get? 10. So this one here will be cutting at y 10, x 20. So in the instance where we double the figure by 2, the income, so instead of 100, we have 200, leaving the other the same. So what will happen? 5 into 100, our x will be what? 5 into 200, our x will be 40. 10 into 200, our y will be what? 20. So you can see here, the equation is doubling from x 20 to x 40, from y 10 to y 20. So meaning this is called a shift. So this has caused a shift outwards. Suppose on the other hand, it declines, your income declines. I'm just talking about income only here. Instead of being at 100, your income becomes at 50. And the other things are the same. So what happens? The x, 5 into 50, we get 10. 10 into 50, we get what? 5. So meaning it is shrinking, it is shifting inwards. So here we're going to 5, here we're going to 10. So this is a shift inwards. So we can conclude that whenever our income reduces, our income equation will shift. So a shift is only necessitated by these other factors besides price that affects demand. It can be by income, preferences, taste, technology, and other stuff. They cause a shift in demand. Now, when we're dealing with prices of one particular variable, what is going to happen is that we are going to have a tilt in demand. Remember, if our original was here and the price of, this is y and x, the price of y increases. So meaning you're going to demand less of that particular good. So this will cause a tilt on y from price of y1 to price of y2. Why? Because your price of y has increased. So in a normal setting, if you hear a particular commodity you buy, for instance, you usually buy 50 loaves, 10 quarter. If the loaves are now at 15 quarter, you'll be buying 20, you reduce on consumption. The opposite will also occur in the opposite. If you hear that that particular product you are buying has become cheap, so your tilt will be outwards. So meaning you are going to tilt outwards, causing you to purchase more of that particular commodity. So this only happens if the price of good Y declines. So meaning you're going to buy more, okay? You're going to buy more of good Y. The same happens for good X. If we are increasing the price of X, it will tilt inwards. You're going to buy less of good X from X1 to X2. This happens only when the change in price for X has done what? Has increased. But on the other hand, when the change in price for X has gone down, meaning you're going to increase the quantities from X1 to X2. This means that you're buying more of a particular commodity of good X. So this is normal behavior in the real setup. So I still go back to our initial example. Suppose your income was maybe 10 kwacha. The price of good X is 5 kwacha, and price of good Y is 10 kwacha. So our income equation, let me adjust the income to 100. So we're going to have 5x plus 10y. So what happens in this instance? So our sketch as it is, divide 5 into 100, we get 20. 10 into 100, we get 10. So it's cutting the y at 10 and cutting the x at what? 20. This is the original perspective. Now what happens if good x now goes to what? Good x doubles, it goes to 10 quarter. So meaning our equation now will change. So 10x plus 10y. So we're going to divide 10 into 100, good x will have 10. 10 into 100 again hits 10. So the only part that will be affected will be the x part because it has what? Increased. So it is tilting inwards from 20 units to 10 units. So this simply implies that because good x has become expensive, we're going to buy less of it. On the contrary, if good x changed and instead of becoming 10 quarter from 5 quarter, it has actually become 2.5 quarter. So our new equation will be 100 is equal to 2.5 x, leaving the other constant. So 10 into 100 is still 10, so the y will still remain as it is. But 2.5 into 100 will give us 40. So this means that there'll be a tilt outwards from 20 to 40. So this tilt will cause the function to come out like that. Now help me, suppose I'll give you just 2 minutes to think through this. Suppose the price of y has changed from 10 kwacha to 20 kwacha. What is our new equation and what will happen to our graph? So on a piece of paper, try, think of what's supposed to happen. I'll give you a minute. So for good y, if it changes to 20 kwacha already compared with the 10 kwacha originally, it's doubling, it's increasing. So even before we calculate, we know that this was 10 against 20 originally. So meaning this good y has become expensive. Inevitably, you should have an idea that it's going to tilt inwards. But to what, we don't know. So we need to calculate. So if our good x remains 5 as it is, then this one just changes to what? To 20. Our equation would be 100 is equal to 5x plus 20y. So 5 into 100, we get what? 20. 20 into 100, we get 5. So the 20 will remain as it is. That's where it will be tilting from. Then the 10 will now tilt downwards from 10 to 5. So this simply means consumption for good y is reducing by half from 10 to 5. So this is what happens when you're dealing with what? Prices that are increasing. So same with good y and good x, the implication is the same. So if the price reduced from 10 kwacha to 5 kwacha, obviously we expect a tilt outwards. So this is consumer behavior. Now, I'm interested in utility. I said utility is simply what? The measure of satisfaction. So in our class, we had explained to say when we're differentiating implicitly, this is our utility function. So du over dx is our x is what we're interested in, leave the y as it is. So we differentiate the 2x squared. So this becomes 6x what? 2. This is called the marginal utility of x. If we are differentiating with respect to y, so du over dy, our marginal utility of y is what we call this. So we leave our dummy as x to the power 3. So what we're going to differentiate is 2y5. So 5 times 2, we get 10. Then y, we subtract the 1 there, we get y4. So this is how we differentiate implicitly. So you need to get used to this differentiation. Let's try again. If we're at 10 y5 x x2. So in differentiate with respect to y, our dummy is x2. Differentiate the y with the 10. So 10y5 will be 50y4. If we're differentiating with respect to x, the shortcut is simply ux, or the magnitude of x. Same thing. So our dummy in this case is y5. So leave y5 as it is. So what are you going to remain with? 10x2. So when you differentiate 10x2, we're going to get 20x1. So when you subtract 1 from this, that is how we differentiate. So remember, differentiation comes from the power rule, which simply states that by differentiating the y over the x, we multiply the a with the n, such that if you have y is equal to 5x to the power 4, we multiply the y over the x. 5 times 4 is 20. And subtract 1 from the 4, we get a 3. That is how we differentiate. We have u is equal to 9x to the power 3. We have u is equal to 9x to the power 1 over 3. The concept is the same. So this is du over dx. Multiply 3 times 9 is 27. And subtract 3 minus 1. So here, what we're going to have is 27x squared. Are we together? So mu x, we want to differentiate. So if we're differentiating here, we're going to multiply 9 times 1/3. So 1/3 of 9 is 3. Then we subtract 1/3 minus 1. So here, our derivative will be negative 2/3. So that is the magnitude of what? Of x. So for you to understand the differentiation that we want to talk about in the constraint optimization, you need to understand basic differentiation. So that is a prerequisite. Okay, so let's try again to differentiate. U is equal to 5x to the power 3 minus 2x to the power 4 y to the power 3 minus 7 y to the power 5. So this is du over the x. We start with one letter. It's called the magnitude of x. Only where there's x, that's where we're differentiating. All right. So here we have the x, so this becomes 15x to the power 2. Here there's x and y, so the y will only remain as it is. It's only survive because it's attached to the x. If there was no x there, this y would be 0 because we consider that as a constant. So 2x4 will give us 8 what? x3. And finally here there's no x, so it will be 0. There's nothing we're going to write there. It ends there. Suppose we're differentiating du over dy. It's a magnitude of y. So since we don't have y in this context, so this will be a 0. But here we can differentiate. We're interested in the y. Leave the x4 as it is. So we're going to have 2y3. So if we're differentiating negative 2y3, what do we get? Negative 6y2. And here, minus 7y5, we get minus 35y4. That's how we differentiate. This is how we get this derivative. So are we following? Are we together? So differentiation is a prerequisite. So I will ask that we don't go into the implicit differentiation until we understand this differentiation here. So just on differentiation, we're going to differentiate these figures. 7y6, 3x2, 2x half, 2x is 2. So when differentiate 7y6, what do we get? 7y6, what do we get when differentiate that? What are we getting? Give me the value. So this is 7y6. Because we multiply 7 times 6 is 42. Then subtract 1 from the power, I get 5. About 3x2, what do we get? So multiply 3 times 2, which is 6. Then subtract 1 from the 2, which is 1. Although 1 is invisible, we don't usually write it. Okay. So we go to another one. We differentiate 2x half. So half times 2 is 1, although 1 is invisible. Then we subtract half minus 1. So this will simply leave us with x negative half. That is how we get the derivative. 2x is an invisible one there. So 2 times 1 is 2. Then x, we subtract 1 from the 1. So it is 2x to the power 0. Any number to the power 0 is 1. So this would be like 2 times 1, which is 2. So in essence, anything with a variable that has no power is that number itself. So 3x is 3. 4x is 4. 5x is 5. And so on. 10x is 10. 1x, people really become confused, is 1. When write x is simply 1 because there's an invisible one there. So this is how the derivatives are supposed to be treated. So if you're dealing with a constant, 2, any constant becomes what? 0, because they don't have what? They don't have any coefficients. So if you're dealing with total revenue, for instance, that is if you have 170q minus 5q squared. So we differentiate this dtr over dq. So this is called the marginal revenue. So 170q, like I said, is 170. 5q squared, get minus 10q. That is how we differentiate. So you must also understand that the language under differentiation changes. So total revenue, when you differentiate it, it's called marginal revenue. Just convert the T to an M. Total cost is called what? Marginal cost. Total profit is called marginal profit. Total product, marginal product of labor. Total product of capital, marginal product of capital. So anything differentiated is margin. Of course, total product comes in the letter Q. So if we're going to differentiate the total cost, which is 5 plus 10Q. So this is DTR, DTC over DQ. So this is called the marginal cost. So when you differentiate the 5, it is 0. When you differentiate the 10Q, what we get is a 10. So differentiation is a very important topic on its own. it's a combination of just what I've just explained. So profit is given by pi. So if we're given profit, so this is the profit over the Q. So this is called the margin of profit. So if we're going to differentiate 1/3 Q3, so 3 times 1/3, it is 1. We never write 1, it's invisible. So on the 3, we subtract the 1, we get a 2. 2 times 6, we get what? -12. When we subtract 1 from the 6, we get a 5. It is an invisible 1. 1 times 6 is what? 6. When you subtract 1 from there, we get 0. So that's 6 there. The 10 is a constant, so we don't do anything on it. Suppose you're differentiating total output. So the Q over the L, this is called the marginal product of labor. So in this case, since there are 2 letters there, we call this implicit differentiation. So don't touch this guy here because it's the dummy. We're going to differentiate 10L3. So when we differentiate that, we're going to get L at 2. Again, you do for the second time, the Q now with respect to the other letter we haven't touched. So this is for the marginal product of capital. So in this case, our dummy is a L3. By the way, the 10 is for both of them. So most people want to think, where is the 10 coming from? So it's like you cut this and paste here. So we're going to remain with what? 10L-K5. Of course, we enjoy arranging them in the order of ascending alphabetical sequence. So 5 times 10 is 50. What happens on the K? You subtract the 1. So this becomes 50L3K4. So it becomes trickier as it becomes easier. So if you have this arrangement here, 2x half y half. So this is du over dx. This is called the marginal utility of x. Our dummy is y half. We're going to differentiate what? 2x half. So half times 2 is 1. Half minus 1 is -half. So it ends there. Then we differentiate with respect to what? Y. This is called the marginal utility of y. Our dummy here is x half. So we're going to have 2y half. So half times 2 is 1. Half minus 1 is -half. So this is how it goes. So I could give more examples and more. If we have x half squared, this came in the exam. So how do you differentiate with respect to x? So our y2 remains as it is. So 10x is simply 10. This one ends there. If you're differentiating with respect to y, our dummy is what? X. We're going to remain with 10y2. So 10y2 will be 20y. 20y. So this is how we differentiate these figures. Sometimes will come just like this, 10xy. So as it becomes very easy, it becomes difficult for other people to comprehend. So here we're differentiating with respect to what? To x. So our dummy is just y. So if we remain with the 10x, what's the derivative of 10x? Simply 10. Again, we differentiate with respect to y. This is for the marginal utility of y. So in this case, we're interested in the y, so our dummy is the x. So we're going to remain here with what? 10y. So 10y, when differentiated, is simply 10. So these are mistakes that people make in differentiation. So this is the easiest differentiation you must know of. Are we together? I've said quite a lot. So I will end here and then give you some homework on what has been done. Thank you so much for your time. Have a great day. Next class will be the 23rd.